Well, it has been a very long time I've uploaded something, literal 3 months, but I came across something unnoticeably interesting today. Have you ever found yourself filling up a form and you come across the password box? Then you enter your desired password and a warning pops up like expecting an uppercase character. And then when you put an uppercase character, you get another warning like password must contain a special character. So how does the website know what the entered password contains? Here comes our hero Regex. A regular expression, shortened as regex, sometimes referred to as rational expression, is a sequence of characters that specifies a match pattern in a string. It is used with various languages as a validifier for text inputs. Let's say that you have to validify an email. We use regex. There are multiple use cases we can explore in this video, and that's why I have put the topics into chapters. Let's see what regex is and what it has to offer. In our pathway of the video, we will have pattern matching of regex, quantifiers, and regex metacharacters. First, we take a look at pattern matching and also negation of pattern matching. This is how we check for specific characters in a string, and we put the characters in third brackets, and it can be a regex sequence. If the string contains these characters in a sequence, then our condition will be satisfied, otherwise not. Likely, we can give a negation symbol inside third brackets, and then regex method will return true if here ABC does not exist in the string. We can expand the list of pattern matching further. Small a to z checks for all the lowercase alphabets in a string. Capital A to Z checks for all the uppercase alphabets in a string. Capital A to Z followed by small a to z in one single bracket checks for all the uppercase and lowercase alphabets in a string. And if we write 0 to 9 in third brackets, it checks for all the numbers in the string. That does well for the pattern matching stuff. Now we take a look at quantifiers. They are symbols that specify the quantity or range of occurrences of characters or groups in a pattern. They allow you to define how many times a particular character, character class, or group should appear in an input string. Here are some of the quantifiers. If we put asterisk, it checks for 0 or more occurrences of the preceding character or group. This means that if we write asterisk after our regex pattern matcher, then it will be returning true if the pattern is happening for 0 or more times in the text that we are checking for. The plus quantifier matches 1 or more occurrences of the preceding character or group. The question mark quantifier matches 0 or 1 occurrence of the preceding character of the group. In second brackets, if we put n, it matches exactly n occurrences of the preceding character or group, and followed by n comma, which matches n or more occurrences of the preceding character or group. N comma m quantifier. This quantifier matches between n and m occurrences of the preceding characters or group. Also, we should know that quantifiers can be applied to individual characters or to groups of characters enclosed in parentheses. For example, if we write AB in parentheses and then give a plus sign, it matches the strings having the AB character once or more. So if we have a string with A and B characters, then this check will return true. Next, we take a look at the regex metacharacters. These are special characters with a reserved meaning. IBM gives a proper documentation of the regex metacharacters, which will be given as a link in the video description. You guys can take a visit at the website. The most used metacharacters are /d, /D, /n, and /w. /d matches a digit character in the string, which is equivalent to writing small a to z and capital A to z as the regex pattern matcher. Capital D matches non-digit characters in the string, which is equivalent to the negation of the small d, or equivalent to writing negation of A to Z and capital A to Z. /n matches a new line character in the string. That means this checker will always return true if there is a new line character present in the string. /w matches any word or characters including underscore. This expression is equivalent to writing capital A to Z, small a to z, 0 to 9 and underscore for the pattern matcher. The most important metacharacter is the backslash. This marks the next character as a special character or a literal. Like for example in regex, we can verify the validity of an email address as A to Z, capital A to Z, 0 to 9 underscore. But then we can also add things like a dot in the email address. but there is a problem. See, the dots are reserved characters in the regex sublanguage, so we cannot directly write them in the regex expression. In this case, we have to use our responsible backslash to consider an identifier as a literal. So we can make the format of the email validifier like A to Z, capital A to Z, 0 to 9, underscore, and then apply the backslash to write the dot. Let's say that we have the email in the variable email and regex expression in another variable. Now after the expression we have written, we will give a plus sign. This indicates that the entered email address must have the starting with the lowercase, uppercase or numbers with one or more matches. After this, we put an @ symbol beside it for checking the @ symbol of the email address. For the domain name like Gmail or Yahoo, we apply A to Z in the regex expression because of course, these domain names contains lowercase characters belonging from A to Z. Now for the dot, we again put a backslash. Since dot is a reserved expression in regex sublanguage, we have to convert it to the literal by putting it beside a backslash. After that, for the DNS of the email address, it can either be .com or .in. So we apply A to Z in the regex expression and then pass 2,3 in second brackets. This means that the expression A to Z at the end can be of either 2 or 3 characters long. And there we have it. It's a valid regex expression to check for email addresses. And that's how we have email validifiers. Let's say we have a phone number starting with 8 or 9 of 10 digits. Here is how the regex validifier would look like for it. We put 8 and 9 at the starting numbers, then allow any number between 0 to 9 to get position, and the length of the numbers from 0 to 9 would be of 9 digits. And there we have it, a phone number validifier. Well, so what about the password validifier we were talking at the beginning of the video? Well, the password validifier of the regex subcode is in the video description and contains a detailed explanation of the same. And by the way, for staying this long, here is a cookie for you for getting a plus in your concepts of computer science.